not all populations tend to grow the same. And not all species reach stable carrying capacity. Some, they do these fluctuations where they'll grow, increase, decrease. But species can be broadly lumped into two different categories. We have the K strategists here and the R strategists. In K strategists, these are the competitor species. They do well in competitive situations where the population size is close or at carrying capacity, and they have logistical growth. R strategists have high and stringent rates of increases, so you can have these populations that will grow very rapidly and then decrease very rapidly, which we call the boom or bust cycles of growth. R strategists, these organisms tend to be very small in size, have short lives, they produce many offsprings. Little, if any, parental care, usually do not reach carrying capacity. They have the boom and bust cycles. Reproductive strategy is to produce large number of offsprings to overcome the high mortality or death rates. These individuals have high biotic potential. Can you think of any examples of different organisms that would be considered R strategists? Yeah, a lot of insects tend to be R strategists. Some types of plants tend to be R strategists, producing many seeds, and hopefully one will be able to germinate into an adult plant. R strategists tend to be controlled by density-independent limiting factors. The population size is irrelevant to the limiting factor. So what do you think an example of a density-independent factor would be? Yeah, these are things that are independent of the population size or density of population size, like light, fire, storms. Right, these are things that are just independent of the actual population. And then you have K strategists. And these organisms tend to be larger, they live longer, produce fewer offspring, provide substantial parental care. Populations typically stabilize at carrying capacity. Reproductive strategy is to invest in few but quality offspring, and they tend to be low biotic potential. Can you think of some examples for K strategists? Yeah, some good examples would be your birds, your mammals, humans are considered K strategists. Those individuals that are putting in the parental care, feeding their offspring, training their offspring, protecting their offspring, K strategists. And these are controlled by density-dependent factors, factors that become more severe as the population grows in size. Can you give me some examples of something that might be considered density-dependent limiting factors? Yeah, these are things like food, tends to decrease as the population increases. Disease, it's another density-dependent. Those are two really good density-dependent. See if you can think of some other ones. So population characteristics, looking at the R and K strategists, we look at the survivorship curves, and you got a glimpse of the survivorship curves with the Google populations that we did. We have 3 stages. We have 1, 2, and 3. It's backwards here. And 3, you tend to have high mortality in the young. 2, mortality equal among all classes, and then only high mortality at old age. And then here we have the population or zero population growth. When stability reaches in the population, the mortality equals fatality. This should be fatality. So those living versus those dying, they're equal. So here you're looking at the different survivorship curves. Can you list which one is 1, 2, and 3? Yeah, the first one, the first is where they die at an older age. Yeah, and you got survivorship type 1. 2 is where they have an equal probability of death anywhere throughout their life. 2. And then 3, you tend to have a lot die at a very young age. But if they get to that older age, they have a more likelihood of surviving. And yeah, you guessed it, 3. Ultimate size limitation. If the world continues to grow at current rates, population will reach 12 billion by 2055. Human population is subject to the same biological constraints as other species: food, disease, independent things, light, fire, weather. With certainty, human populations will ultimately reach carrying capacity and stabilize. Disagreements about the exact size and primary limiting factors are still up in the air. And there are some great videos from the additional videos to watch on human population problems, human population growth. You can see how some people agree with and some people disagree with population, overpopulation, and population sizes.